Today we're going to review perimeter and area of rectangles and squares. This should be a major review topic, so I'm going to go kind of fast. We are going to look first just at reviewing what these words mean. Perimeter, remember, is the total distance around, while area is the total amount of space inside. So let's look at an example. Pretend this rectangle is your backyard, okay? If we're talking about total distance around, which is our perimeter, it would be like building something around the outside of your yard, such as a fence. So if you were going to go to Lowe's or to Home Depot and buy fencing material, you would want to know your total perimeter. Whereas the space inside, which is our inside here, would be your area. This would be something like how much grass seed you need. So grass seed would be covering the area, and fencing would be covering our outside, which would be our perimeter. So that's the difference between the two. So let's look at these shapes that are right on side of a grid. When you have a grid, it's really great because when in doubt, you can always count. But what we're going to see is how that counting might lead us to a formula, which will give us a really quick, easy way to do something. So let's take this first shape, which is on our grid. And it is a rectangle. And when I look at it, I first look at its dimensions. Now remember, the dimensions are things like length and width. So if I count it up, I realize that I've got 1, 2, 3, 4, 5, 6 as my length. And then my width is another 1, 2, 3, 4. So this is a 6 by 4 rectangle. So when it comes to actually finding my perimeter, which we know is the distance around, I could physically add up these numbers. I could actually count, oops, sorry, that's not 6, that's a 4. I could go ahead and I could just pretend that here I am, and I'm going to walk alongside the outside of this rectangle where it goes 6, another 4 is 10, another 6 is 16, and another 4 is 20. So by just counting, I find out that this is 20 units. If I'm looking for the total space inside, again, I'm looking at the amount of squares that are inside. So I've got 1, 2, 3, 4, 5, 6 again, and I have 4 rows of that. So I really have 6, 12, 18, 24. So my area in this case is 24, and again, since it's about how many squares are inside, we call this square units. So I really can just go ahead and I can count. And I could do that for the other two, and we'll look at those in a second. But what we start to see is that we could actually start doing this a little bit easier than counting. So we start to have these things called formulas that start to emerge from our work. And we came up with a formula, for example, that says P equals S plus S plus S, and I usually just do dot, 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 because the P is a variable standing for perimeter, and S is standing for sides. So all we're doing is adding up those sides. So now I could just say, well, I could do P equals 6 plus 4 plus 6 plus 4, and I would still get my 20. Or some people start looking at it and saying, well, hey, a rectangle is really 2 times the length plus 2 times the width. And then some people even take it further and start realizing that you have the distributive property here, that 2 is a common factor, so we could do 2 times L plus W. So those are all formulas that we can use. When it comes to area, we also start to see a nice formula come up, that we start realizing that if we that every time when we get our answer by counting, we start to realize that A is the same thing as doing LW. And again, L is standing for length. We're just using variables, and W is standing for width. And we start to see these formulas. We have 2 ways of doing it. So let's take another example that's on our grid. I'm going to go with the second one here. Now again, I'm trying to find P, and I'm trying to find A. I could definitely count up. What I'm noticing with this rectangle is that it has a width of 3, and it has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, a length of 8. So I could go ahead and I could just do a count around. And really that's, again, going with that formula, P equals S plus S plus S, and in this case, another S. And what I'm really doing is doing 3 2 times and 8 2 times. Those become my sides, and then I could just simply add them up. And I have a 6 plus 16, which is the same as 22. And again, we're just doing units because we're counting around. With area, again, I can count up. I already know that there's 8 in a row and there's 3 rows, so I'm predicting it's 24. But again, if I use my formula, A equals LW, and I just plug in my width or my length of 8 and my width of 3, I do get 24. And again, because we're looking at how many squares are inside, we're going to call these units squared. So we've used our formula again. When we come down to this last one, again, it's always about what's most efficient. In this case, honestly, I might just count them up. In terms of the inside, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I already know my A is 10 units squared. I don't need to use a formula. It's obvious, because in the end, I would just be doing 10 times 1. Now, in terms of perimeter, I know my length is 10, and I have 2 of those. Plus, I have the width of 1, and I have 2 of those. So I'm kind of using my formula right now, but I'm doing it kind of quick, and I get 20 plus 2, so my perimeter is 22. Which is interesting because this one was 22, and this one was 22. So it just goes to show you that you can have different shapes, things that look different, but yet have the same perimeter, and that's something we've been investigating. So whether you decide to count using perimeter or area, or you decide to use a formula, it's really about being distance around for perimeter and total space inside for area. And this should be a major review concept since you've been doing this since probably 3rd grade. And now we're going to be using that information to really help us look at other shapes that will include triangles and parallelograms. So be on the lookout for that video coming soon.